run all the programs, so I'm going to go get that in today. But inverses. Hit or miss yesterday, who remembered? If this was our original function, would you remember that the inverse flip-flops the x's and y's and is a mirror image across the line y equals x? Would you have remembered that? Yes, because that's the part most people don't remember. What they do remember is if 0, 2 is on our original graph. And I hate the terminology because they call this a function, but it's not a function until we do the vertical line test and look at our points. But if the original graph has 0, 2, that means the inverse flip-flops those x's and y's and has the point 2, 0. That's what most people remember. Tonight, we're not going to do the homework in the packet. I've got an extra sheet that practices the meat and potatoes, not the extension. We'll practice the extension on Monday. But if I give you a graph and ask you to find the inverse, all you have to do is find the points and flip-flop them. But let's do a quick review because we're going to have a term here that's new, but you need to remember what we talked about before. Does our original graph in pink, does he pass the vertical line test? Okay, so that means that he's a function, correct? And that means if he's a function, I'm not going to take time to pick the points, but let's pretend these are the points on that graph. Since he's a function, do you agree that that means each x has its own y, right? Each x does not branch off. Okay, we're going to talk about a new term called one-to-one here in a minute. And before we do that, though, would this guy be a function? Yeah, the y's repeat, though, but that's okay. Our x's don't. If you are one-to-one, and I'm going to bring this up when we get to it, your y's have to be unique as well. But talking about a function, we would do the vertical line test. It's a function. To see if its inverse is going to be a function, anybody remember from Algebra 2 the horizontal line test? The HLT? If your original graph is a function and passes both the vertical and the horizontal line test, that means your inverse is a function. Because sometimes we don't have the inverse graph, and we have to figure out everything from the original. If you do have the inverse graph, you could do the vertical line test on it to see if it's a function. But without it, you could just test the original one. All right, so first thing you need to remember, every graph and its function are reflections across the line y equals x. Anybody remember the function notation? I had one person remember it yesterday. Function notation. It's got an f, and it's got an x, but there's something up high in between the f and the x. -1. And it's not an exponent. It's an actual math symbol that denotes the function. Yep. All right. So that should be ringing some bells. When we have a function in its inverse, when the x's flip and y's flip-flop, that means the domain of the original becomes the range of the inverse, because the x then becomes the y, and the range of the original becomes the domain of the inverse. If xy is on the original, we just talked about that yx is the function. And our meat and potatoes of our work tonight is if two expressions are truly inverses of each other, their compositions, our work that was due yesterday, simplify to x. So when I compose my original function with the inverse, and vice versa, if you get x, that proves that they're true inverses of each other. And if they're true inverses of each other, that means they're symmetrical with y equals x. It means their x's and y's are flip-flopped. It means the function and its inverse both pass the vertical line test. And it also means they are one-to-one. You probably touched upon that last year. But one-to-one, all that means is your function has the x's that are unique, and your inverse has your x's and y's that are unique, which means every x has a unique y. That's all that one-to-one means. Okay. Today we're just going to do the algebra stuff, or tonight, over the weekend. You're going to have a bonus point opportunity. We're not going to do the graphing stuff for homework, but we'll talk about it in a minute. Okay. Can I move on? Joey, you good? Emma, you good? Yep. All right. So, if each value of our dependent variable, who's the dependent variable, guys? Is he x or y? It's y. Like, so if you have a graph, the money you make depends on the hours you worked, right? So the money you make is the dependent. If the x variable corresponds to the independent variable, oops, I lied. Oh, you guys could have gotten the point. The x, which means if your function, your original function, passes the horizontal line test, then the function is said to be one-to-one. That could be a really good short answer essay at some point. Maybe a Collins writing assignment talking about what does one-to-one really mean. Okay, so let's look at this. This curriculum cracks me up because they expected you to automatically look at that graph and come up with the equation. That is not the purpose. Hi.
Coffee machine eyes here. I don't think it's going to be running for one day.
Okay.
There's a more.
Yeah. Okay.
Just so you know.
Thank you. 180 has one working. 180 is not. So, Thank you. All right. So, visual vocabulary. You know, if you have a function and its inverse, it should be symmetrical with the line y equals x. At the very end, we'll answer that question. We're going to write the equations together and we're going to find algebraically. This is what you're going to do tonight. But just looking at this, does anybody remember what type of parent graph that is from section 1.6? Is that like a reflex? Okay, what do you think? Okay, he says x cubed. Joey, what do you say? Square root. Anybody want to break the tie break?
Square root.
Square root. Yes. So let's just, for fun, for poops and giggles here, just see if the parent, and you don't need this, don't graph this, but let's see if we can do it. If that's the parent, can anybody tell me how it was shifted? What do you think, Eli?
To the left, and down 2.
To the left 3 and down 2. So how would I represent to the left 3? Anybody agree with that? Yeah, is that right? Do we agree? So you could have done it. So I guess I shortchanged it. But that's not our work. I want to focus on proving or finding the inverse algebraically. Graphically, if we sketch the line y equals x, okay, and mine is off, and I can't even blame my contacts today, all these points should reflect against that. Yes, dear?
Should we skip that or are we coming back to it?
Skip what, this guy?
Yeah.
We're coming back to it because it says we have to get all 3 graphs done before we figure out which ones are one-to-one.
Okay.
But I couldn't fit all 3 on here. Okay, so do you agree if this point right here, which is -3, -2, is on our original graph, what would be the point on our inverse graph? Can anybody tell me that? Yes, dear?
-2.
You got it. -2, -3. Why do I so have a feeling you guys are going to get a point out of me on this? Okay. Is this 0, 1 on our original? Or 1, 0? If this is 1, 0, what's the point on our inverse? 0, 1. All right. Let's see. Can we get one more point out of here? How about this? If this guy is 1, 6, it's going to be 6, 1. Yep. So up here. So the graph of our inverse, do you agree, is going to be something like that? And had I drawn my line y equals x, better, it would have reflected over it. But that's how you take an original graph. Did I mess up?
Would the original point for that one be 6, 1 because it's x before y?
Oh, yeah. Whew, you're not going to get lollipops with that one. Okay. Yes, 6, 1. Thank you, Madison. So this is 6, 1. And then I still got this one right?
Yeah.
Okay. Whew. Oh, dear heavens. You're not getting lollipops out of me. Tim.
You're missing a point.
Which one?
-1, -2.
-1, -2. Yes, I only just graphed 3, but I could have done that one as well.
Okay.
Yes, the more the better, the more accurate. Phew, I thought you'd get a point on this. So, on Monday's assignment, you're going to be given a graph and told to graph the inverse. But all you do is pick the points and flip-flop them. The meat and potatoes of this lesson is actually finding the inverse algebraically. What letter can we replace f of x with, kiddos? Who's f of x interchangeable with? Y. I don't know, you tell me. Okay, so to find it algebraically, you start by replacing your function with y. In an inverse, what is flip-flopped, friends? X and y. So guess what? To solve algebraically to find the new one, you flip-flop x's and y's. And then all you do is solve for y. So let's make a little note. First step, let's do it up here. 1, you're going to replace f of x with y. 2, you're going to flip-flop, no flip-flops today, x and y. And then 3, you're just going to solve for y. And when you get that done, you have your inverse equation. So back to our algebra days, what's the first thing I would get rid of to isolate the y term? Go ahead. Square root, yes, but could we get rid of the 2 first as well? Yeah, I would kick him to the curb, and I'm left with x plus 2, and then we're going to get rid of the square root like he said. How do I get rid of the square root? Anybody remember? Square it. So, x plus 2 quantity squared equals y plus 3. I have almost solved for y. What's the last thing I need to do, Eli?
Subtract 3.
Yes, so I am out of room. So I'm going to jog over here. Alrighty, so our final answer, we have x plus 2 quantity squared. We don't need to simplify. Eli told me to subtract 3, and that's it. Are you surprised that's a parabola? Because look, isn't this kind of the right-hand side of a quadratic? Yeah, just thought you should have. But listen, we can't have 2 people named Y's. That's like a mom naming all their kids Jim. What is he? What did we just find? The inverse. You have to rename. Did you remember doing that last year? Yes, Max.
How would we know not to graph the parabola like both sides?
You're just, so like your lowest point would be that guy, that would be the first point of your other. Just go off of the original equation.
Okay.
That's a very good question. Yep. Now tonight you're not going to graph. You're just doing this, and then you're also going to prove that they're inverses. But let's look at this one. So let's go back actually to the question Joey asked. Which of the functions is one-to-one? Did our original function pass the horizontal or the vertical line test?
Yeah.
Would the original function have passed the horizontal line test if we did not graph the new one? Yes. So that means A is definitely one-to-one. Now that we have the inverse, you could test it with the vertical line test. So when it passes both, it's an inverse. So this guy, all right, the equation, and you should have been able to get it, f of x equals, anybody agree with x squared minus 2? Right, because it's our basic function, right? So Max, on this one, can you see how it gave you both sides?
Yeah.
So that guy, then we would, for the inverse, graph both. But I want to concentrate on the algebra right now. This guy, if we looked at the domain restrictions, there are none because we only have an x squared minus 2. No square root, no denominator. What was our first step to find the inverse algebraically with the last one? Yes?
Switch to the left.
Yep. And then you're going to flip-flop the x's and y's. When I solve for y, what do I get rid of first? Plus 2? Let's change colors here. The more you show me, the more partial credit I can give you. On your quizzes that we'll get back Monday, some of you tried to do stuff in your head for one of the plugging in a negative x one, and you missed it, and I couldn't give you any credit, and it really bothered me. All right, what do we need to remember when we take the square root ourselves? What are we tacking in, Max?
Plus or minus.
Yes. Okay. That is our inverse. If you want to just get in the habit of that last step, rewriting it, instead of taking a whole nother line, that's fine. Okay. Now, before we even try to graph that, the original passes the vertical line test. But does the original pass the horizontal line test? No, that means it's not one-to-one. That means that this new inverse is not going to pass the vertical line test. For time's sake, I know that you guys can get the ordered pairs and flip them. But that is what the inverse looks like. And you can clearly see that the inverse is not a function. So it's not going to be symmetrical. So this is a relation. It is not a function, so it is not one-to-one. Okay. If I asked, you would have to restrict because we have a radical. Okay. One more, and then we're going to learn how to compose both ways, or review how to compose both ways. Do you remember doing this? Is it ringing a bell? Or is it easy? I think it's kind of fun because it's actual problems. Okay, so this guy, f of x, if you graphed him, you should not be, or if you did it yourself, surprised that that's the equation. I lied. That is not the equation. You're going to have all the equations tonight. Let's do this. This was one I don't think you could have gotten on your own. He is the cube root of x plus 1 because he's sideways. Had he been vertical, it would have been x to the third plus 1. Okay. Since it's a cube root, you don't have to worry about negatives under the radicals. So our domain is just going to be all reals. All right, I'm going to let you walk me through starting this. First step. Mr. Sutherland, what do you think? First step. Who am I replacing? Yep. If you are on the ball enough, you could flip-flop and replace at the same time. That's fine. I'm not going to... You could have done the 2 steps in green all at once. How do I get rid of the cube root? What do I do to both sides? Cube it. Yes. Okay. And I'm left with y plus 1. take the 1 to the other side, and I'm just gonna go straight to my inverse. That is him. The new one would look like this, something like that, and he would be symmetrical with the line y equals x. And that's because the original passed the vertical and horizontal line test. Okay, same thing. I have one more type to show you. We might just be able to get it done in one, and then we'll be done. We are going to skip the next page front and back. It's not worth us wasting our time, so we're not even going to come back to that. And the very last thing, and we might knock this out today, our final answer to your line there is A and C. 2 did not pass the horizontal and vertical line test, but everybody else did. But the last thing we're going to do, these procedures for finding the inverse is what we have done. Tonight, you're not going to sketch anything, but you are going to find the inverse and verify that their inverse is algebraically. So, to find the inverse, it's what we've done automatically. You replace your f of x with y. You flip-flop your x's and y's. And then when I solve for y, I get x minus 2 equals a negative y squared. And I'm going to let you guys help me out here. What do I do? Joey? Yeah, well, can I get rid of that negative? Is that what you were saying?
Oh, x plus 2.
Yeah, get rid of that negative, multiply everybody by that negative 1, divide by it, however you see it, and it would be negative x plus 2. And then what'd you say, Joey, you did? Okay, and then I'm going to square root it. Absolutely.
Why? Why wouldn't you put square root bar and then
It is. You are one step ahead of me. And again, you could just go straight to that's your inverse. That should not be a problem, okay? Now, when this happens, I'm only going to have you do the positive root for the next step. So write it both, but to show that they're true inverses algebraically, when I compose, I'm just going to have you use the positive root. So to show algebraically, you are going to put in your inverse and compose. And then you're going to do it backwards. If they get x, you will see that they are true inverses. So, when I plug in, I'm going to write my minus, the negative x plus 2 and square it. I'm taking my inverse, plugging it in. What happens to my radical when I square it? Emma?
Wait, what if you put 2 times something else?
Right there. Good question. What happens when I square my radical? Does it stay or go away? Joey? Yep. And I'm just left with 2 minus a negative x plus 2. Because when I square it, it goes away. When I distribute, you end up collecting your terms and getting x. And here's the thing. If one of these directions gets x, the other one is. And when we both compose and get x, we have a function proven inverses algebraically. So then, you're going to do it the other way. You're going to take your original function and plug it into your inverse. There's a lot of work here. That's why you're only doing the odds. But what this tells me to do is take my function, 2 minus x squared, and plug it in for my inverse. Okay? So, my inverse is a square root of negative x plus 2. I'm gonna, instead of x, I'm gonna put in 2 minus x squared plus 2. When you do your arithmetic, everything's gonna cancel and you're left with a square root of x squared, which is x. And when you prove both compositions equaling x, you have a function.